Hello everybody, this is Plus 8 Precision, and this is my Sheldon Lathe. I acquired it in July of 2018. The lathe itself needs some work. It's a 240 three-phase motor. Right now I have it hooked up to a static phase converter. It runs, the motor runs, all the speeds work. It has back gears, 4 speeds with the underdrive Sheldon Lathe setup. So you have 4 speeds direct and then 4 speeds in back gear. The problem arises when you need to use the carriage, which is pretty important and pretty regular use on a lathe. The gears on the Sheldon Lathe, on the gear train, are worn. I also have some wear in the quick change gearbox and some wear on the 2 dogs on the quick change gearbox, or tumblers, whichever you prefer. In this close-up shot, you can see the gear that is the cleanest has the most wear. I've had that off, did some measuring, and I've actually purchased a gear that somewhat fits. I've got to machine that on my other lathe in order to get it to fit into place. I'm referring to this gear here in the back. That gear seems to be a gear that has a lot of issue. I believe it is bronze, maybe like an Amco bronze type material. But the teeth are pretty well shot. I could disassemble it and show you that. You can also hear the difference when the lathe is running, that there is a significant amount of gear slop there. And consequently, that caused other issues, I believe, within the quick change gearbox due to the timing of the gears and the timing of the lead screw. So that is one thing I've got to fix. Again, I've got the gear. I just have to take the time to machine it so it fits properly. And the gear next to it, this gear, has some wear and probably should be replaced at the same time, which I don't have a gear for that yet, but I can pretty much buy one off the shelf. It's not that big of a deal with slight modifications. Mainly the actual machining of the through hole. It's a 9/16 through hole, and the gears come with a 1/2 inch through hole. Not that big of a deal. And then there's some machining on hub face and what have you. But that's the main wear in this portion here. This is all set up for standard threads, not metric, although this lathe did have a metric attachment and gear set for it. I don't have that. The gentleman I bought it from didn't have that. Okay, here's a view inside of the quick change gearbox. Nothing's moving, it's all static. I just want to kind of demonstrate how much wear is on these tumbler gears. It's the bushings, but you can see how much slop there is as I'm moving this. Those bushings are shot on the shaft. So it does cause problems with the gear alignment as well as some wear. And on this gear here, in the far back side, there is some wear. There's actually a step there. You really can't tell on camera. So that gear, I don't know if I can like turn it around or if I'll have to replace it. So I'd have to disassemble this whole thing, which I do plan to do. Measure out all the gears, and then see what I have available and what I would have to make. Luckily, I do have a smaller Atlas lathe where I can do most of this work at to bring this lathe back up in very usable but old condition. I'm just going to give you a quick demonstration of the gears with everything running. It's going to be quick because everything is grinding and I don't want to make anything more worse than it already is. So here you go. As I said, it's not pretty. You can force things in and kind of hold it with your hand and it'll run, but it just, I don't think it's worth it to do any more damage than's already done on this lathe. So that's about as much as I'm going to show you on that. The purpose of this shot is simply to show you how fairly quiet the lathe is without the gear train engaged, and then the difference once the gear train is engaged. So let me show you that now. And then we will simply engage the gear train, and let's do it again. Not very pretty. Not very healthy. In this shot, I'm going to show you how the back gears work. So right now we're in direct drive, low speed. I'm going to turn it on, show you, turn it off. So you can see we're direct drive. Back gear is back here. It's not turning. I'll engage it. Show you how simple that is pretty much to do. So there's a pin right here. We pull that like that, and then the back gear lever is back here in this area. There's a little knob you pull and simply engage the back gear. Maybe you can see that knob now right here. Double check that. It's out. And you'll see how much slower it turns. This would be the slowest speed on the lathe. We're at 30 RPMs on the chuck in this position. In this shot, you can plainly see the apron of the lathe. I'll explain the controls. There's another video on YouTube that he goes into quite a lot of detail. It's kind of cold here, so the clutch is not working exactly right. So I can't really demonstrate that. I wish I could. It's very similar to a south bend, but so here's your longitudinal feed, cross feed, and then this is your compound feed, which is a little bit stiff right now. Again, the lathe needs a good going over. But this is your position lever. Each of these will determine whether you're feeding on your cross slide or your on your apron, or you're feeding on your cross slide. This is your half nut here, and then this is the clutch, which simply turns in until you feel it engaging. You have this functionality here. This position is for a cross feed. This position is neutral. In this position, which is the far right position, is for feeding your carriage. In any one of these positions other than neutral, the half nuts are locked out, so they can't engage. In this shot, you can see the underdrive system and how involved it is, with several pulleys and the levers all going up to the spindle assembly. We turn it on so you can see it run. We can switch speeds by simply moving this lever and then checking our engagement. Here I've changed its positions again. And the final position is with both levers to the left. That's the highest speed on the lathe. Sometimes the way this static converter is, it doesn't really have enough horsepower to get it started in such a high gear on this lathe, which I believe is 720. We'd have to take a double check the tag. And I guess finally here we have the tailstock, maybe the least exciting part of the lathe. It's pretty straightforward. The lock is here. The spindle lock is up here. It does have approximately 3 inches of spindle travel. And it is a number 2 Morse taper, which I can show you here. This is the only attachment that I have with the lathe. So I guess this probably concludes everything I know about the lathe. There wasn't a lot of information, again, other than the story of how the gentleman acquired it, where he purchased it from. I've done quite a bit of research online. I joined the Yahoo Sheldon Lathe group, which there's quite a bit of information in there. Not so much on this, it's the other styles. This one seems like it's a little bit more unique. I believe using the Yahoo Sheldon Lathe group information as reference that this lathe is probably from the early 50s. The number on it is 17636, and I believe that falls in between, say, 1952 and 1953. I'll include a page from the Sheldon Lathe group where that information resides and what other members have fed back. And I use that as a reference point for the age of this lathe. I have no other documentation. So if anybody has any questions, let me know. Leave it in the comments. Email me, however, and I'll try to answer it. I will get through this project. It will be running. All issues will be fixed. I don't know how long it'll take, but I will document it as I proceed. I don't think I will get overly crazy with doing a full restoration and stripping the paint down to the castings and repainting it all. I will clean it up. I will make sure everything is working properly. And that's as far as I will take.